G'day and welcome to the second of the Year 10 math presentations. This looks at the topic of simultaneous equations and takes two approaches. We call one the graphical approach and one the substitution method. But don't get too worried about all these words. When we see it in action, we'll understand what we're doing. A great place to start is just to ask the question, what are simultaneous equations? On this graph, we've got two lines drawn. This first line is the line y equals 2x plus 1. This second line is y equals x plus 5. We can actually just stop for a little bit of revision and say, well, if the line is in the form y equals mx plus c, m is the gradient and c is the y-intercept. So this should have a y-intercept of 1 and a gradient of 2. Well, if we look at the graph, the y-intercept where it crosses the y-axis is 1, and the gradient, well, it goes up 2 and across 1, so it has a gradient of 2. That makes sense. So simultaneous equations are two lines, and the solution for a simultaneous equation, what we're looking for is where the lines actually cross. So in this case, these two lines cross at the point 4, 9. So hopefully things aren't looking quite as complex now. All we're looking for is a point where two lines cross. Another important question is, where would we use this in real life? Let's consider these two lines here. This first line might be the costs involved, the income made. This line here is the income made from a business selling coffees. The more coffees you sell, the greater your income. This top line is the costs. So you've got a bunch of costs associated with selling these coffees. And the two lines cross at this point here. So why is this of interest? Well, all down here, your costs are actually greater than your income. So you're making a loss. This point here is where you go from making a loss to making a profit. Suddenly your income is higher than your costs, which is a great thing to see. So we go back to, what's this point? Well, it's the point 4 coffees sold and $9 of income. That's the point at which your income and costs are equal and you start making money from there on. Let's go back to this idea of the graphical method. It sounds impressive, but what it means is we're going to draw two lines and we're going to read off the graph where the 2 points meet. So, the first line is this equation y equals 2x plus 1. The second is the equation y equals x plus 5. Now, we've already talked about this revision. We've said that when you've got the standard form of a linear, which means a straight line equation, y equals mx plus c, the gradient, m is 2, and the y-intercept c is 1. We could use that to draw our lines, but let's do a table and say, okay, let's make x equal to 0, 1, 2, 3, and 4 and work out what y is. So, when x equals 0, y equals 2 times 0, which is 0, plus 1. We just substitute 0 in wherever we see the x, remembering that when there's no symbol here, that's a multiplied by sign. So 2 times 0 plus 1 is 1. The second point, x equals 1. We've got 2 times 1 is 2 plus 1 is 3. The point is 1, 3. The next point is x equals 2. 2 times 2 is 4 plus 1 is 5. So y equals 5. And so on to complete that table. We do the same thing here. Our second line is y equals x plus 5. So, when x equals 0, y equals 0 plus 5, which is 5. When x equals 1, y equals 1 plus 5, which is 6. When x equals 2, y equals 2 plus 5, which is 7. Now that we've got our table with the two lines, we can just graph these lines. So here they are drawn on the graph using the points that we've actually found. We can now look at this graph and say, well, it's not that hard to see where the two lines are going to cross. They're going to cross right here at the point 4, 9. X is 4, Y is 9. When we talk about points, remembering we put the X value first, so it'll be 4, 9. So this becomes our solution. The lines cross at the point 4, 9. Now, an important piece of revision is this. If lines have the same gradient, they're never going to cross. They're going to be parallel. We can't solve them as simultaneous equations because there's not going to be a point where they cross. So if we consider these two equations here, y equals 2x plus 3 and y equals 2x plus 7, they're never going to cross. We can't solve them using simultaneous equations. Now let's look at this substitution method. There's a fair bit of writing on this slide, but let's not get too worried about it. We'll just go through it one step after the other. We have to solve, or are asked to solve, these simultaneous equations. And I've used exactly the same one so we can see and compare it to what we did in the first question where we used the graphical method. So our two equations are these. Y equals 2x plus 1, y equals x plus 5. They're just two linear equations and we have to try and find where they cross. Now, we can see that in the case where they cross, the two y values are going to be equal because it's one single point. The two x values are going to be equal, one single point. So what we can do is say, well, let's substitute the value of y for 2. So in equation 2, y equals x plus 5, let's substitute that into equation 1 for the value of y. Remembering y is going to be the same in both points, both cases, because it's the point where it crosses. So when we do this, we've got that x plus 5 equals 2x plus 1. Now we can use our algebra and say, okay, we want to try and find out what x equals. How are we going to get x by itself? Well, in this case, we could subtract x from both sides. What you do to one side when you've got an equal sign, you have to do the other. So if we subtract x from both sides, we get that 5 equals 2x minus x, which leaves us with x plus 1. Now to get x by itself, we can take away 1 from both sides, and we get that x equals 4. So we found this value that x equals 4. Once we know the value of x, we can substitute back into the equation 1. We've done this a fair bit. We were even doing this in the graphical method to find out points. And we can say, okay, let's look at this equation, 2x plus 1, and we'll say x equals 4. Remember, it is 2 times x. We'll substitute in 4 where we see the x and become 2 times 4. So y equals 2 times 4 plus 1, y equals 9. So the point of intersection is x equals 4, y equals 9, or the point written x, y is 4, 9. Now this is not an easy thing to do, so let's have a look at another example. We've got two different simultaneous equations to solve this time. The first equation is y equals 2x minus 1. The second equation, y equals x plus 5. Now we're looking for the point where these two lines cross. So we're looking for the point where the two y values are the same. So we can substitute the value of y in equation 2, which is x plus 5, into where we see y in equation 1, because we know that value is going to be the same. We say that in this case, x plus 5 equals 2x minus 1. And now we're on to our algebra to try and solve this. So we're thinking about how can we get x by itself. Remembering if we do something to one side, we have to do the other. So the first thing we can do to get rid of x and get all the x's onto one side is subtract x from both sides. So when we subtract x from both sides, this side becomes x minus x plus 5, which is just 5. This side becomes 2x minus x, which leaves us with x minus 1. Now to get rid of the 1 and find out what x equals, we add 1 to both sides. We've got that 6 equals x. So now we've found the value of x being 6. So we can substitute this into one of the equations to find the value of y. We could use either, but let's use equation 1. So the equation is y equals 2x minus 1. And we've said we know that x equals 6. So what's the value of y when x equals 6? We've got 2 times x. Well, that becomes 2 times 6 when we substitute 6 in wherever we see x. 2 times 6 minus 1. 2 times 6 is 12, minus 1 is 11. So therefore, we know that these simultaneous equations cross at the point 6, 11. This is the last example and a little bit trickier, but we should still be able to do it. It just involves slightly more complex algebra. Again, we're given two equations. Two equations, in this case both for straight lines, and we were asked to find out what's the point at which these two lines cross. So we've got that y equals 5x plus 3. So what we can do is we can say, let's say in the second equation, wherever we see y, we'll substitute in 5x plus 3. So 4x plus 3y equals 47. We're going to substitute in 5x plus 3 wherever we see y. So, in this case it becomes 4x plus 3 times 5x plus 3 equals 47. Now we need our algebra rules to expand out these brackets, get rid of these brackets. So when we've got this 3 in front, it's 3 times 5x, which is 15x, and 3 times 3, which is 9. When we put these things together, 4x plus 15x is 19x plus 9 is 47. So we can get x by itself by taking 9 from both sides. So 19x equals 47 minus 9, which is 38. So x equals 2. Now we've found the value of x, we can substitute this value back into equation 1 to find the value of y. So even if you found x a little bit tricky to do, this is a very similar step to what we've done previously. Here's our equation. Y equals 5x plus 3, x equals 2. Remembering this is 5 times x plus 3, we substitute x equals 2 in. That means wherever we see x, we put a 2 in. 5 times 2 is 10 plus 3 is 13. Therefore, the value of x is 2 and y is 13. So the point where the line crosses is the point 2, 13. Just made a comment here. It looks a bit funny if I try to line up all the equal signs. There are big gaps in the working out. But in your bookwork, it's always best to have your equal signs lined up so you know what's happening on both sides of the equation.